For centuries, physicists have sought a single, elegant theory that could explain the fundamental workings of the universe. This quest has driven some of the greatest minds in history, from Newton to Einstein, and continues to inspire scientists today. This theory would not only explain the universe and all its complexities, but also unify the various forces and particles that govern the cosmos. It would be the ultimate framework, a master key to understanding everything from the tiniest subatomic particles to the vast expanse of galaxies. We call this elusive idea a theory of everything. It represents the pinnacle of scientific ambition, a theory that could potentially answer the most profound questions about the nature of reality. Today, we may be closer than ever to achieving this dream. Recent advancements in both theoretical and experimental physics have brought us to the brink of a revolutionary breakthrough. A groundbreaking new theory has emerged, promising to unify the two pillars of modern physics, quantum mechanics and general relativity. These two theories have been the cornerstones of our understanding of the universe, yet they have remained fundamentally incompatible. Quantum mechanics governs the bizarre world of the subatomic, where particles can exist in multiple states at once, and probabilities rule. It has given us incredible insights into the behavior of particles at the smallest scales. Quantum mechanics has revolutionized technology, leading to the development of quantum computers and other cutting-edge advancements. It reveals a world that is both strange and fascinating, where the rules of classical physics no longer apply. General relativity, on the other hand, describes the large-scale structure of the universe, explaining gravity as the curvature of space-time caused by massive objects. It has provided us with a deeper understanding of phenomena such as black holes and the expansion of the universe. The new theory suggests that the universe's fundamental forces are not separate. Instead, they are all interconnected manifestations of a single underlying force that operates across different scales. This unified force theory proposes that what we perceive as distinct forces, such as electromagnetism, gravity, and the strong and weak nuclear forces, are actually different expressions of the same fundamental interaction. This force, they argue, behaves differently at different scales. At the quantum level, it gives rise to the particles and interactions we observe, governing the behavior of matter and energy in the smallest realms. At the quantum level, this unified force manifests in the intricate dance of particles, influencing their interactions and the fundamental properties of matter. It is the key to understanding the building blocks of the universe. At the cosmic level, it manifests as gravity, shaping the evolution of stars, galaxies, and the universe itself. This unified force governs the large-scale structure and dynamics of the cosmos, from the formation of galaxies to the behavior of black holes. This theory, if proven correct, has the potential to revolutionize our understanding of the cosmos. It could provide a comprehensive framework that unites all of physics, offering new insights into the nature of reality and the origins of the universe. It could unlock some of the universe's most enduring mysteries, such as the nature of dark matter and dark energy, the behavior of black holes, and the ultimate fate of the cosmos. The implications are truly mind-blowing. Join us as we explore this groundbreaking new theory and its mind-blowing implications. Together, we will delve into the cutting-edge research that is pushing the boundaries of human knowledge and bringing us closer to a unified understanding of the universe. Our current understanding of particle physics relies on the Standard Model, a framework that has been developed over decades through meticulous research and experimentation. This model describes the fundamental particles and forces that make up our universe, including quarks, leptons, and the fundamental forces like electromagnetism and the strong and weak nuclear forces. While incredibly successful in many respects, the Standard Model has limitations that have puzzled scientists for years. For instance, it fails to incorporate gravity, one of the four fundamental forces, and cannot explain certain observed phenomena, such as the existence of dark matter and dark energy, which make up most of the universe's mass-energy content. To address these gaps, scientists are developing new theories that go beyond the Standard Model, aiming to create a more comprehensive understanding of the universe. One such theory introduces the concept of a unified field, a single, all-encompassing entity from which all forces and particles emerge, potentially unifying gravity with the other fundamental forces. This unified field is thought to permeate all of space-time, acting as the underlying fabric of reality itself. It interacts with particles in ways we are just beginning to comprehend, suggesting a deeper level of interaction that could explain many of the mysteries that elude current scientific models. According to this theory, the interaction between particles and the unified field is responsible for the behavior of particles at both the quantum and cosmic levels, providing a bridge between the very small and the very large. To visualize this concept, imagine a pond with fish swimming within it. In this analogy, the fish represent the particles, and the water represents the unified field that surrounds and interacts with them. The movement of the fish creates ripples in the water, just as the presence and movement of particles distort the unified field. These distortions, in turn, influence the movement and behavior of other particles, giving rise to the forces and interactions we observe in the universe. This radical departure from traditional physics has profound implications, challenging our current understanding and opening up new avenues of research and discovery. It suggests that the laws of physics as we know them may not be absolute, but rather emergent properties that arise from deeper, more fundamental principles. These emergent properties could be the result of interactions within this unified field, hinting at a deeper reality that underpins everything we observe. This deeper reality, governed by the unified field, holds the key to understanding the true nature of the universe, potentially unlocking answers to some of the most profound questions in science and philosophy. Einstein's theory of general relativity revolutionized our understanding of gravity. It was a groundbreaking shift in the way we perceive the universe, moving away from Newton's classical mechanics. It described gravity not as a force acting at a distance, but as the curvature of space-time caused by mass and energy. This elegant theory provided a new lens through which to view the cosmos. The new theory takes this concept a step further, delving deeper into the fabric of reality itself. It suggests that space-time itself is not fundamental. Instead, it is an emergent property arising from something even more profound. This new perspective posits that space-time is an emergent property of the unified field, a concept that unifies all fundamental forces and particles. Imagine a piece of fabric stretched taut. This fabric represents the space-time continuum, a smooth and continuous entity. If you place a ball on the fabric, it will create a dip, representing the curvature of space-time caused by a massive object. This is how gravity is visualized in general relativity. Now imagine that the fabric itself is made up of countless tiny threads woven together. These threads are the building blocks of the unified field. These threads represent the unified field, the fundamental framework from which space-time emerges. The new theory proposes that the interactions of these threads, governed by the unified field, give rise to the fabric of space-time itself. This intricate dance of threads creates the reality we experience. This implies that time and space, as we perceive them, are not absolute. They are fluid and dynamic, constantly shifting and changing. They are fluid and dynamic, constantly being woven and rewoven by the underlying tapestry of the unified field. This dynamic nature challenges our traditional notions of a static universe. This has mind-boggling implications for our understanding of reality. It suggests that what we perceive as solid and unchanging is actually in a state of constant flux. It suggests that the universe is not a static stage upon which events unfold. Instead, it is a dynamic and ever-evolving entity. It is a dynamic and interconnected web, where time and space are inextricably linked to the fundamental fabric of existence. This interconnectedness hints at a deeper unity underlying all of reality, a profound connection that binds the cosmos together. Section 4, Unlocking the Cosmos, the Quest for Dark Matter and Black Hole Secrets. The universe is full of mysteries that continue to baffle scientists. Two of the most perplexing are dark matter and black holes. Dark matter, an invisible substance that makes up a significant portion of the universe's mass, has only been detected indirectly through its gravitational effects. Black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape, present challenges to our understanding of physics. The new theory offers potential solutions to these cosmic enigmas. It suggests that dark matter may not be composed of exotic particles, as currently theorized. Instead, it could be a manifestation of the unified field itself, interacting with ordinary matter in ways we do not yet fully comprehend. Similarly, the theory provides a new perspective on black holes. By considering gravity as an emergent property of the unified field, it may be possible to develop a more complete understanding of these enigmatic objects. This could shed light on what happens at the singularity at the center of a black hole, a point where our current laws of physics break down. Section 5. A glimpse into the multiverse, exploring the unthinkable. The concept of a multiverse, the idea that our universe is just one of many, has long captivated the imaginations of scientists and science fiction enthusiasts alike. While still purely theoretical, the new theory lends credence to this mind-boggling possibility. If the universe is indeed a dynamic tapestry woven from the unified field, it stands to reason that other such tapestries could exist. These other universes, each with its own unique properties and laws of physics, would be causally disconnected from our own, making them incredibly difficult to detect. However, the new theory suggests that subtle interactions between these universes may be possible. These interactions could manifest as anomalies in the cosmic microwave background radiation, the faint afterglow of the Big Bang. By studying these anomalies, scientists may be able to find evidence of other universes, providing a glimpse into the vast and unknowable multiverse.